Alright, welcome back to Algebra. We are in Chapter 7, Section 2, Multiplying Polynomials. We're going to do most of this with examples rather than just rules. Okay, remember that when you're multiplying, if you have a set of parentheses, remember we use the distributive property. Now if you're multiplying 2x times x times x is x squared, so that would be 2x squared, and then 2x times 5 is 10x. Okay, so that's distributive property using a monomial here. X times x, remember when you multiply variables, their exponent changes. Alright, now if you're multiplying two binomials, you could do distributive property. They call this the FOIL method. F-O-I-L, that's first, outside, inside, last. So you would multiply the first terms like this. Then you would multiply the outside terms like this. That'd be the outside terms. Then you would multiply the inside terms. And then you would multiply the last terms. And that's it. Now, that works when you're multiplying binomials, but once you get to trinomials, you're going to lose track. So, instead, we're going to use a method that works with any of these, and that's the box method. So, I'm going to put a little box, a line right here, a line underneath this, where the second polynomial is, and then I'm going to take the first one, and I'm going to write it vertically. I'm going to have 2x right there. Put a line under that, and then plus 3 right here. Where that plus is, put a line down, and now finish that box. 2x times x is 2x squared. 2x times 5 is 10x. And then 3 times x is 3x, and 3 times 5 is 15. Now we still have to combine like terms. Usually, in most cases, this top left term is going to be by itself, and the bottom right term is going to be by itself. It's these diagonal cases that are going to have like terms. So we can start with the top right term, 2x squared. Now, the diagonal ones, 3x and 10x, gives me 13x, so plus 13x. And then the bottom right here is just 15. Now I have no more like terms, and it has resulted in a trinomial. Alright, we're going to do the same thing here. Make a box, write down x, put a line under that, and then negative 2. Very important that you bring down that negative also. Alright, x times 3x is 3x squared. X times 4 is 4x. Negative 2 times 3x is negative 6x, and negative 2 times 4 is negative 8. Again, this term, top left, is by itself. That's the greatest exponent. Then we have diagonals. 4x minus 6x, or negative 6x plus 4x, either way you do it, gives you negative 2x, and then negative 8. The term bottom right is by itself again. Okay, this is where it's really useful to have a box, alright, because now we're multiplying with a trinomial. So we put the 6x here and the plus 5 down here. Put a line, make a box. Everywhere we have a sign, we'll put a line. That rhymes. 6x times 2x squared is 12x to the third. 6x times negative 3x, the sign in front of a number goes with a number, is negative 18x squared. 6x times negative 5 is negative 30x. 5 times x squared is 10x squared. 5 times negative 3x is negative 15x. And 5 times negative 5 is negative 25. If your exponents are in descending order without skipping one, so here we have 1, 0, 2, 1, 0, then your like terms are going to be diagonal from each other. Okay, so that's one way you can check to see whether you did it right, because if you have an x here and an x underneath it, then maybe you did something wrong. So here we have 12x to the third, 12x to the third, that's by itself because it's top left. Then these diagonals are x squared, so 10 minus 18 is negative 8x squared. Negative 15, negative 30 is negative 45x. And then bottom right, we've got negative 25. And here, finally, a trinomial times a trinomial. Fun, fun, fun. Make a little box. Write this vertically. 2y squared, line, 3y, line, and negative 1. Now we'll fill out our box. Alright. And start multiplying. 2 times 3 is 6. Y squared times y squared is y to the fourth. 2y squared times negative 5y is negative 10y to the third. 2 times 2 is 4. Y squared. 3y times 3y squared is 9y to the third. 3y times negative 5y is negative 15y squared. 3y times 2 is 6y. Negative 1 times 3y squared is negative 3y squared. Here we have positive 5y and negative 2. Now I can check to see, are all my exponents lined up? 3, 3, yes, 2, 2, 2, and y, y. Okay, very good. These are lined up, these are lined up, and these are lined up. Alright, so I'll start with this one. That's the greatest exponent. Then combine these. 9 minus 10 is negative 1 y to the third, or just negative y to the third. Negative 3 minus 15, negative 18, plus 4, negative 14. Y squared, 5 and 6 gives me positive 11 y, and then finally this one's by itself, minus 2. There you go. That's about as crazy as it gets here. Now, they might give you an expression like this where they say f of x is 3x plus 2 and g of x is x minus 1. What is f plus g of x? Okay, that means just the first function plus the second function. So that would be 3x plus 2 plus x minus 1. So if we're adding, we just combine like terms, put a 1 in front of the x if it doesn't have a coefficient, make that 4x, and then 2 minus 1 is 1. And there is your answer. F minus g, then we would do 3x plus 2 minus x minus 1. Now subtracting, remember we're going to change all the signs in here, make that plus, make that minus, make that plus. That way we don't lose track of what we're doing. 3x minus 1x gives us 2x. 2 plus 1 gives us 3. And then f times g of x. Okay, f times g of x, that's f of x times g of x. So we're going to take f of x, 3x plus 2, times x minus 1. Alright, now we're multiplying binomials, so box, boom, plus 2. 3x times x is 3x squared. 3x times negative 1 is negative 3x. 2 times x is 2x. 2 times negative 1 is negative 2. 3x squared. 2 minus 3 is negative 1x minus 2. There you go. Now they might rewrite this expression here, say, well, that's f of x plus g of x. And they might have you rewrite this as f of x minus g of x. Now the tricky part, that looks kind of like distributive property, but this is of x. This is a function. So here, distributive property would just make that fgx, but this is not distributive property. This is the function f and the function g of x. So that's the function of x times the function of g. Okay? I hope you don't encounter this. It's nonsensical, but there it is. Alright, and here's a tricky problem. In hockey, a goalie apparently can only play a puck in this trapezoid back here, in this trapezoidal region. Alright, and that trapezoidal region is given in these measures. We want to write a polynomial that represents the area. Now, the area of a trapezoid is 1/2 the height times base 1 plus base 2. Okay, so we're going to have 1/2, and the height is x minus 7, and then times base 1, x plus 10, plus base 2, x. Alright, so now we have 1/2, x minus 7, and then 2x plus 10. What order we multiply in doesn't matter. So what I'm going to do is I'm going to rewrite this and say that's 1/2 2x plus 10. Can you guess why I did that? Think about it. Pause and look at this. Why did I do that? Because both of these are even, so if I do 1/2 to each of these, I just get x plus 5, and then multiply that by x minus 7. So x plus 5, that gives me x squared, and negative 7x. Down here I get 5x, and negative 35. So x squared minus 2x minus 35 is the polynomial. They said find the area if the shorter base is 18, the shorter base is x, that means x equals 18. So 18 squared minus 2 times 18 minus 35, and that is 253 feet squared. There you go. There you have it. Good times, lots of fun in the Matherhood. Check in again next time for another fun lesson. And if you have stuck around, here are a couple of freebies. Find the area, write a polynomial. Area of a triangle is 1/2 base times height. So I'm going to use base and height. Now since I'm multiplying, I'm going to write this one first, because both 2 and 6 are evens. So when I multiply those by 1/2, I get p minus 3 times p plus 1. And then I'm going to line that up here. But it gives me p squared and 1p, negative 3p, and negative 3. So my polynomial is p squared. Negative 3 plus 1 is negative 2p, and then minus 3. Make sure to write down the work for this. Line this up, f plus 1. Make a little box. F to the third, 4f squared, 8f, f squared, 4f, 8, and then combine like terms. That gives us f to the third plus 5f squared plus 12f plus 8. Boom. There you have it.